Let us summarize the different parameters of FET. Gate cutoff voltage, right? So we are aware that gate to source voltage is going to control the drain current that is flowing from drain to source from the field level transfer, right? So definitely gate to source voltage is the controlling variable for this current, right? So we are aware that the as soon as the gate to source voltage is more, gate to source voltage is made more and more negative, right? Up to the value of pinch of voltage, right? VP, right? At that time, at that case, when value of VGS equals to minus VP for n channel FET, right? Then we get a minimum value of ID or negligible current ID. So, right? Or we can say that the current is so minimum that device is off, right? Device is off. So yeah, so that voltage is nothing but this cutoff voltage. So instead of VP, we can write VGS off or cutoff voltage. So modified equation is ID equals to IDSS into 1 minus VGS upon VGS off whole square. Okay, that was the cutoff voltage. That should be equal to the pinch of voltage. Shorted gate drain current. So yeah, shorted gate drain current. That is IDSS. Okay, IDSS. So when we get it, when we keep VGS equals to 0, when we keep it VGS equals to 0, and as soon as we increase drain to source voltage up to VP, right? That is pinch of voltage. And after pinch of voltage, if we again increase the drain to source voltage, we will get the constant current, right? That constant current is called shorted gated drain current, and it is represented by IDSS, right? That we already studied, right? Now, every device is having its resistance, right? So we have already formulated the resistance, that was the dynamic resistance, right? Now we have to formulate the transconductance. So what is a transconductor? It is nothing but the conductance offered when we transfer the input current, or we supply something input to the device and we get the resultant output. So it is nothing with the formulation between input and output. So the conductance between input and output. So input is what? Gate to source voltage, and output is what? Drain current. So the amount of drain current that should be varied up with amount of gate to source voltage. Okay, that will give us what? The transconductance, and inverse of transconductance is resistance, that is the voltage upon current. So inverse of resistance is transconductance, that is current upon voltage. So we have to draw it between input and output. So output is drain current and input is gate to source voltage. So change in drain current with respect to change in gate to source voltage while keeping constant drain to source voltage. So that value is what? Transconductance, and it is denoted by GM. Okay, and we will get the maximum value of G, right, when we keep VGS equals to 0. Okay, and so the value of GM is also going to vary, right, because we vary this G's get to source voltage, right? So because of that, ID is also going to vary. So GM is nothing but variable value, right? It is going to be a variable, right? Yeah, similar to that dynamic resistance, right? So when VGS is 0, we will have the maximum transconductance, and it is denoted by GM, right? Okay, and if we formulate that we are transconductor in the form of GM, so we will get the equation in the form of like GM equals to GM into 1 minus VGS off, right? So how we get it? We have the formula ID equal to IDSS into 1 minus VGS off square. We have to take derivative of ID, right? We will take derivative of ID with respect to GS, right? So ID upon VGS, right? Del ID upon del VGS. So after taking the derivative, we get this equation like this. So IGM is equal to 2 IDSS upon VGS off, right? So GM is equal to IGM into 1 minus VGS upon VGS. This is the formulation for transconductance, right? Yeah. So for FET, transconductance is very important for speed of operation. Yeah. Dynamic output resistance, right? As we already discussed, output resistance will be also effective, right? So how we calculate voltage upon current, right? Voltage upon current. So output, so what we have, output is drain current, but what at the same time we have the drain to source voltage, output voltage. So change in output voltage with respect to change in that output current, right? So VDS, change in VDS upon change in ID, that will give us the dynamic resistance, right? It is dynamic because we just say yeah, whatever the value ID current is going to vary, right? So that, that's why we call it as a dynamic variable. So dynamic resistance. Okay, let us see amplification factor. Yeah, so of course there is going to be amplification factor uh, in case of FET. So how we calculate this? Yeah, amplification factor. It is nothing but change of output about change of input voltage, right? So what is output voltage? That is drain to source, and input is get to source. So del VDS upon del VGS, right? At constant ID. Okay. So if is this the formulation, then we can put up the value of this del VDS upon del VGS equals to, like, um, in this way, del VDS upon del ID into del ID upon del VGS. So right. So we have the formulation for del VDS ID as RD, right, and del ID upon del VGS as GM. So amplification factor mu equals to RD into GM.